An AGV battery can appear adequate on paper and still fail in operation. A pack with enough nominal amp hours may trip during acceleration, charge outside the available window, or leave the vehicle controller without reliable state of charge data. For warehouse and manufacturing fleets, battery procurement must therefore begin with the complete operating system: traction inverter, charger, fleet scheduler, safety controller, payload, route, and maintenance process. The first decision is voltage compatibility. Voltage affects the traction inverter, contactors, charger, DC bus, and low-voltage accessories. A 48-volt class system may use different nominal and charging voltages from a 51.2-volt Leaf APO4 configuration, even when both are described using the same market label. Request the exact pack's nominal voltage, full charge voltage, minimum operating voltage, protection thresholds, and allowable voltage variation. The connector alone is not enough. The controller must recognize the voltage curve, the charger must terminate correctly, and regenerative energy must remain within the BMS acceptance limits. Wiring diagrams, connector pinouts, protection ratings, and the charger profile provide the evidence needed for integration. The second factor is usable capacity across the actual duty cycle. Amp hours alone do not predict runtime or fleet availability. Usable energy depends on voltage, discharge limits, temperature, load profile, and permitted depth of discharge. Record average and peak power for travel, lifting, steering, computing, sensors, and standby states. Include operating hours, task frequency, route gradients, floor conditions, and payload distribution. Then calculate usable watt-hours using the proposed voltage and discharge limits, with a documented reserve for aging, temperature, scheduling variation, and emergency recovery. A representative route test should validate the result before fleet release. Current capability is the third factor. Continuous current describes sustained demand, while peak current covers short events such as acceleration, lifting, turning under load, and climbing. Both ratings require context. The supplier should state duration, ambient temperature, state of charge, measurement location, and allowable voltage drop. The specification should distinguish normal travel current, sustained maximum current, short peak current, and regenerative current. Discharge curves, current limit behavior, alarm timing, and reset conditions can reveal whether the pack reduces power gradually or shuts the vehicle down abruptly. High current combined with low state of charge, cold cells, or conservative protection thresholds can trigger unexpected cutoff. The fourth factor is BMS communication and diagnostics. The BMS monitors cell voltage, temperature, current, state of charge, and state of health while enforcing protection limits. For an AGV, it also determines whether the vehicle controller and fleet platform can use battery data effectively. CAN, RS-485, and SM-Bus are interface options, but a protocol name is not an integration specification. Request the physical interface, baud rate, message identifiers or registers, scaling rules, update rate, alarm codes, command permissions, and firmware version. Protocol mapping should be completed before sample approval, followed by a bench test with the actual controller. The fifth factor combines mechanical, thermal, and compliance evidence. Review dimensions, mass tolerance, mounting points, cable exit direction, connector access, center of gravity, service clearance, lifting method, and replacement procedure. Thermal claims must identify whether they apply to charging, discharging, storage, or short qualification exposure. Request low-temperature charging rules, high-temperature derating, sensor placement, ventilation, and condensation controls. Certificates and factory test records must be tied to the proposed model and batch. Goldencell, also presented as JGNE, provides a public case example with configurable ranges from 25.2 to 51.2 volts and from 10.8 to 102. 6 amp hours, models listing working currents up to 75 amps, Leaf APO4 chemistry, CAN, RS-485, and SM-Bus communication, and stated cycle life and temperature information. These specifications support initial screening, but final approval still depends on model-specific drawings, logs, protocol records, sample testing, and traceability. A defensible procurement sequence is straightforward. Define the duty cycle, confirm voltage and charging architecture, calculate usable energy, specify continuous and peak current, map BMS communication, review installation and thermal constraints, verify documentation, test a representative sample, and compare its results with the released production specification before batch delivery.